Always curious about what I could do with my experiments and how I could integrate and embed them into application experiences. And this is very early on when Azure Machine Learning was available in preview, and there was very little content that was going to tell me how I could successfully integrate my experiments into applications. So the emphasis on this is to explain how to integrate into a .NET application, but there's probably going to be some requirement for you to understand, well, what is Azure Machine Learning? How do we develop an experiment? Then how do we deploy it? Then how do we integrate it? So the intention is an ambitious one for this 60-minute session, and is to go through the entire life cycle of how Azure Machine Learning can be used to develop predictive solutions and then how to integrate them into an application. Very briefly, my name is Peter Myers. I'm a data platform MVP of 10 years. My specialty is really working with SQL Server, analysis services, reporting services, and anything that's related. And so Azure Machine Learning comes in there as something to supplement my skill set into cloud services. Let's begin with describing what machine learning is. We'll then introduce what Microsoft are offering as a cloud-based machine learning service with Azure Machine Learning. I'll demonstrate the full cycle from data preparation right through to delivery in an application. And then we'll finish off with some inspiration for you on how we might use Azure Machine Learning in other business scenarios. So humans have this interesting need to know what could be. All right, and if we take a look historically, we've seen that business people might consult the services of a clairvoyant. And I'm not sure what you think of this approach to predictions. It's certainly not grounded in good science. But interestingly, historically, we've seen examples of even presidents consulting with clairvoyants to understand or determine military strategy. We're not going to suggest that. Another approach might be referring to mollusks and their incredible ability with high degree of accuracy to even predict the outcome of World Cup matches. But can you imagine going to your IT manager and suggesting that you install an aquarium of octopi to help you with the predictive needs of your business? Probably not a practical one. So let's talk about good data science in the topic of machine learning. And let's begin then with a definition that machine learning as a subfield of computer science and statistics that deals with the construction and study of systems that can learn from data rather than follow only explicitly programmed instructions. Let's put this into an example. If you need to respond to a question that is, what happens or what's the result of adding two numbers together? It's fairly basic, as you'd appreciate. We could build a function that passes in number 1, number 2, and using a language like C#, we could produce a response and a reusable function. That's pretty basic. But let's consider this question a lot more different. I need to predict customer profitability. And you would recognize up front the need for a function whereby if we pass in customer demographic state, age, gender, marital status, and so on, we would like it to output some prediction of what profit might be generated from this customer. So you begin with your favorite language, and I'll use C# here, and you produce a method, predict profit class, and you pass in all of those demographic states. What are you going to write as fixed logic to take those inputs and output a prediction? And the fact is, if you're taking this path, well, I'm sorry, you're on the wrong path. All right, we're going to suggest that you take some good quality data that represents some history of your customers defined in terms of rich demographic values and also some history of what profit they have produced for you. And then using machine learning algorithms, they will sift through looking for patterns and correlations between the different demographic states and the profit, and we would then query this as a model. And we could query this real time, as I'll demonstrate today. So in fact, this introduces the demonstration that I'll produce for you today, producing a machine learning solution that will predict customer profitability. Where do you think that might be useful in an application? What might we drive in an application experience if we have an understanding of what profit a particular customer may deliver to us? Financial advice? Possibly. I'm thinking more generally in an e-commerce scenario, what might we do with that intelligence?
Recommendations.
Recommendations? Yes? Right, so how might we inspire those that might deliver higher profit or higher sales from us? So recommendations is one approach, or targeted advertising is the approach I'll take today. Let's not just randomly choose adverts. Let's choose adverts that are more likely to attract the different types of customers, whether they're low profit delivering customers or high profit. All right, so when we produce a machine learning project, the flow often follows this path. With any project, you want to define quite clearly what the objective is. So the objective here would be we need to determine with a degree of accuracy what profit we're likely to attract from a customer. Next, we look for some data. What data do we have available? And if I had a CRM system, that might provide some richness in detail of a customer. If it's an e-commerce application, we're likely to have a profile for the customer. When they registered to shop on our website, hopefully we collected some good responses to a number of interesting questions, and that will help us out when it comes to a machine learning task such as this. Now, we don't accept that data as good to go. We are always deeply suspicious of the quality of that data. All right, so we spend good time and effort preparing the data to ensure it is in optimal and highest quality possible. And then we're ready to move into the machine learning process, which involves training models. Note the plural here. We don't create just one model and say, she's great, deploy and use. In fact, there's two tasks that go hand in hand. We define models in terms of an algorithm, inputs, parameters to tune the machine learning process, and an expectation of outputs. All right? And we create lots of these. There are so many different variables and variations you can work with. Ultimately, you're going to arrive at the one that best fits your purpose, typically in terms of reliability and accuracy. And then we will deploy this as a model. And once published, Azure Machine Learning would deliver this as a web service. From a management point of view, we'd want to ensure that it's available and scalable. And then from an application experience, we can then integrate this in some meaningful way. In an e-commerce application, let's use it to drive real-time targeted advertising. All right, so up front, a discussion on what roles might interact with machine learning. So a little bit of an experiment here. I'm asking you to tell me a little bit about who you are. This is completely optional. Could I just ask you to jump to this URL, either use the QR code or the tiny URL I have here. There are 5 questions. Please be as accurate as you can. This is in fact a Power BI dashboard. It's a real-time delivery of your survey results up here on the dashboard. And we'll just do a quick assessment of who you are. And I'll give you about a minute to submit your responses. Okay, we've got a Kiwi in the room. So as I'm expecting from an audience like this, that you're a majority software developers. So managers here are likely to evaluate what we've got on offer here. I'm looking to see whether there are any data scientists in the room. So far, no one admitting to it. All right, so thanks very much. 23 submissions. By the way, as a plug for a session I'm delivering this afternoon, Power BI for the developer, we're going into a lot more detail on how we can deliver real-time dashboards programmatically. All right, so what I was looking for was the submissions by role. So you can see the bar chart here showing me that predominantly software developers, as I'd expect at a conference like this. Back on track then with the discussion of roles. A primary role that you will hear with machine learning will be the data scientist. So with no data scientists in the room, usually I call them out, and the question I would ask them is, how much do you earn a year? And before they answer, the embarrassment is enough. What you're going to discover is there's a worldwide shortage of technical skills to drive the needs of businesses today. And that need is to deliver deep intelligence and meaning from data sets. All right, so the data professional such as me, I'm a generalist, business intelligence, I work with OLAP and reporting, but really we're looking for people that are highly skilled in statistics, mathematics, computer science, and that can solve complex data problems and that's what the data scientist does. Now, it's a primary role associated with machine learning, but what I will emphasize in this session is that machine learning is becoming approachable for professionals like myself and like yourself as software developers. So with not just focusing on the data scientists, I would suggest that those that have fundamental and basic data skills, whether that's just defining relational database schemas, is a good start that is enough to prepare you for some interesting adventures in the machine learning world. The next one, of course, is the software developer that may produce machine learning solutions, but are likely to integrate machine learning solutions into application experiences. All right, when it comes to the challenges for machine learning, well, skills or shortage of skill sets. So traditionally, machine learning, there have been great barriers of entry because of the requirements for hardware, software, and the skills to run this. This is becoming more approachable by services that I'm about to introduce with Microsoft's Azure Machine Learning. So all up, it's typically expensive in terms of hardware, the skills. There might be lots of different tools required to deliver that entire workflow that I've introduced to you so far, and undoubtedly it is quite complex. The consequences of this are that if you don't have it, you're either not being as efficient as you could in business, or you're relying on a lot of guessing and estimations that may not just be so accurate. And what we could suggest to you is that if you could improve the predictions just by, let's just suggest a 1% improvement by the relevance of suggestions that you feed back to your customers, with the volume of hits and browsers that take place on your website, that 1% improvement can translate to tangible financial benefits that could easily justify the cost of these types of projects. All right, well, let's now introduce what Microsoft are doing in this space. So Azure Machine Learning is a cloud-based predictive analytics service. It's designed for professionals, and not just data scientists, as I hope to convince you in this session, but a range of professionals, including data developers and software developers. And that armed with nothing but a browser and good internet connectivity, you have a very powerful service available to you to start experimenting with your data. And when you experiment and produce something that you think is valuable, you can easily deploy and operationalize. And as a web service, you can then integrate this as a predictive capability into an application experience. The data that it can work with, so bearing in mind that it is a cloud-based service, so cloud data stores, whether it's Azure SQL databases, Azure SQL Data Warehouse, HD Insight is Microsoft's big data platform. You could also access data in virtual machines. If you need to work with on-premises data, two approaches. The first is you can push the data up for storage and then access by the service, or in preview, you have the ability via a gateway to allow SQL Server on-prem data to be available to Azure Machine Learning. How does it work? Well, there's an Azure portal that allows your Azure Ops team to provision a workspace in Azure Machine Learning. There's ML Studio, that is a browser-based design tool that will allow you to experiment and publish. And then lastly, you have an API service that allows you as a software developer to connect to and integrate into an application experience. So working through the entire cycle, I'm going to be wearing the hat, just for the moment, of the Azure operations team, and I come to the Azure portal, and here under machine learning, I create a new workspace. So let's just call this the NDC Sydney. And there are only 3 data centers in the world supporting this today, and I will create a new storage account, also named NDC Sydney, assuming that no one else has taken that.
Is the South Asia one based in Australia?
Southeast Asia, no, it's not. I believe it's Singapore. As simple as this, within 30 seconds, we're going to have a workspace. The next step would be that the Azure Ops team would then add in users so that within the workspace they can collaborate on data sets and also experiments. So we'll come back to this in a moment. We'll move forward and then start working through that entire flow from defining the objective right through to managing an integration. So within the context of my example, and that is looking to predict the profitability of my customers. So it's very important to have a clear objective, and certainly in a machine learning project, unlike other data-related projects that I would work on, they're usually multi-objectives. It's like we might use it for reporting on sales and profitability and various analytic requirements. Whereas in a machine learning project, it's extremely narrow in focus. It's going to do one thing. Hopefully with good accuracy and reliability, it's going to predict the profitability of my customers. So back to that question. I need to predict customer profitability, but some more information to deliver targeted display advertising on the company e-commerce website to both present relevant product suggestions to also increase sales and profitability. With that in mind, we then move on and say, well, what data do we have to support this? And knowing that I want that function, pass in customer demographic details and pass out some prediction of profit, I would be looking internally, perhaps externally, for valuable data sets. It could be a CRM system, it could be the data warehouse, it could be the OLTP system that drives the e-commerce. Ultimately, what I want is as much good quality data that represents my customers and their behavior. So here in demonstration, I'm going to show you that I have a very simple data set. It is my customer's profit. It's a CSV file that I'll open up in Excel. And here I have 10,000 rows of data. So let me go ahead and select and make this into an Excel table. And by the way, this is Office 2016. So when I have an Excel table on my data ribbon, I have the ability to get and transform. And so this is a really cool tool to allow you to both explore and understand the data and maybe also further prepare it in meaningful ways. So let's just take a look at the data. We have the unique ID. Is that going to be valuable in predicting profit? Is there any value in it whatsoever? Yes, correct. So we can link it to a sales system, but as far as a set that would be used for machine learning at this point, is there much value in it? So, data scientists wouldn't necessarily dismiss it so quickly. They might suggest that a sequence might tell us, how old a customer is. In the absence of a join date, we might actually use that in some way, but today we'll suggest that it's not that useful. What about first and last name? That someone's first name is Peter or Paul, would that impact on profit? Yes or no? Maybe. So we might just leave it open and say, well, let's just see what happens. Let's just throw it at an algorithm and see whether it finds any relationship between name and profit. Certainly in the absence of gender, which we in fact have, you might use libraries that know that these names are male versus female. So you might actually use it to construct other attributes that either you don't have or you have missing data in them. Yearly income. It's been pre-discretized into 25,000 groups. All right. Now that's probably because in the e-commerce website, when they register as a new user, it's a drop-down list. These are just the values that were available to them. We didn't give them a text box and say, to the dollar and cent, tell us how much you earn. That's sort of a bit of an imposition on privacy, right? Now, up until here, these are all demographic details, and here's where it's becoming really interesting, that we've joined to the sales history, and with a knowledge of the total cost of sale, we can produce a profit. And to be very, very careful here, we've suggested that these are the profit for a 12-month period. You can't just say the total profit over all time, but in the last 12 months for these 10,000 customers, this is the profit that they have generated. All right, does anyone know where the data came from? It's not real data. It's one of my favorite databases, which is the Adventureworks data warehouse. All right, so I have some good quality data. That is an absolute prerequisite. All right, so the next discussion would be about preparing this data. So significant amounts of effort really need to be given to ensuring you have that data that is representative in the best possible quality. That might mean transforming the data to fix it, to cleanse it, change data type, standardize, maybe even isolate or flag abnormal data. What would we do if we discovered abnormal data? Flag it, but would we remove it? Would we keep it? You'd need to refer back to your objective. All right, if my objective was, I'm looking for abnormal data, i.e. fraud detection, then you want to keep it. And in fact, you might use statistical techniques that would oversample it and exaggerate it as part of your preparation, such that machine learning algorithms would learn that and see that very clearly. In this case, we might then determine, okay, anomalies, they skew the results, we'd actually remove them. So depending on your objectives will depend on what actions that you take. Substitute missing values. We'll come to this one in a minute. Of course, and here's a word for you guys as developers, that when you're designing applications today, machine learning is probably not a #1 priority for you, but certainly I'd ask you to bear in mind that you should start capturing and maintaining good quality data so that machine learning is a viable option for you in the future. For example, in an e-commerce application, if you simply say, when you register, that all we need is your email address and a password, there's not a lot that you're going to machine learn from this. Yet if you came in and had a profile that said, right, go ahead and provide us details about your nationality, your gender, etc., and you maintain this, have you noticed from time to time that Amazon will ask you to go back and review your profile? So keeping it current is also part of your responsibility for ensuring you have quality data sets. I often use an example of the Afghanistani accountant problem that you might come across with data sets. And I ask you to think for a moment why that might be a problem. Afghanistani accountants, you find that when analyzing your data set, you find a number of them and they stand out. Yeah, so the software developer has decided, let's just make life easier for our new customers. Let's just default to the first item in the list. All right, and what do your customers want to do? They're eager just to get to the shopping cart, check it out, pay, and have it delivered. So if you provide defaults to the first item in a drop-down list, well, you're going to jeopardize the quality of your data. So Afghanistan is the first country, accountant is the first profession. Now, often what would happen at this stage is that you would have such an abundance and they would skew results that you're forced either to remove the entire attribute, country or profession, or the cases. Those individual customers would simply need to be removed. So something as simple as that, ensuring that you have no defaults, can dramatically improve the quality and therefore the volume of data and therefore the quality of the machine learning that you can perform. All right, so let's see in demonstration that just taking that raw data set, the way that I might prepare it, first of all, I'm going to make the decision that first name and last name would be removed. And this is an important point, certainly for some customers in certain countries, is that in recognition that this data set is going to be pushed up to the Azure Machine Learning workspace. And so in some countries it's illegal to send personally identifiable information to storage up there. So I'm just going to use the functionality here to remove these columns. Age looks good, marital status, single or married, gender, male or female, discretized income. Next, when I look at the total children, and in fact I notice that there are some nulls here, so I've got some missing data, and there are just 10. So 10 out of 10,000, I can live with this. I can easily make the assumption that they have no children. And then I'd have a chat to the software developer and say, could you please ensure that new registrations don't allow a null entry, that they have to choose some valid value. Now, when we look at the number of children at home, and if I group by, and this is what I love about this tool, is it's just easy to understand your data, but I can see a significant volume, in fact, almost 50% of the number of children at home. So I'm going to make the decision that we don't have enough quality. I can't repair this easily. So I'm going to go ahead and remove this column also. And that's a bit of a loss. Like with the nationality and profession, to remove that is going to impact on the quality of what I can achieve with machine learning. The rest comes down to education, occupation, do they own a home, how far do they travel, and then we come to profit generated. So with a consistent or a continual numeric value here, I need to think carefully about what I'm doing. I'm looking to predict the profitability of customers. And am I looking to predict to the dollar and cent the profit they might generate, or am I more interested in a generalization of what profit they will deliver? And the answer is I'm looking for a generalization, and I make a decision that I'm going to categorize each of these customers as either a high, medium, low, or very low profit generator. Because when we think about it from a marketing perspective, when we have targeted advertising, we don't have adverts to the dollar and cent. They're really bucketed. Here are the adverts we want to show a high profit generating customer, and here are the adverts that we would show a very low profit. So I'm going to translate this value into a label, and that can be achieved by adding a column, and I'm going to name this the, what are we calling it, profit generated label. And I'm just going to use a language here. Does anyone know what language this is? That if profit generated is less than 100, then I'm going to classify this as very low. No, it's not VB. Power Query, and it goes through an informal name. It's a single letter, and it's not R. Nope. M. Right, so it is indeed M. So using the language of M, I come up with logic here that says these are the labels that we will assign. Now this is something you want to play around with a little bit, and let's just do a quick group by to understand the distribution across the 10,000. All right, so I've got about 4,200 low and I have about 1,700 high. And so I've arrived at the end of the data preparation phase. So what I'm going to do is just close and load. And it takes that transform query result and loads it back to a new sheet within the workbook. Here is my prepared data. And then I'm going to go ahead and save this as a CSV. So let's just save it to my assets. And I'll call this the customer profit prepared. And as a CSV file, I can upload this to the Azure Machine Learning workspace. And let me finish on that task. So now that the workspace has been provisioned, the ops team have added in users, and then those users can sign into ML Studio. And so just simply by using a web browser, they can go ahead and start working with data by uploading data sets and creating experiments. So the first task will be, here under data sets, I'm going to create a new one from a local file. And that gets pushed up. Now, that's data preparation happening on my desktop. And for the volumes of data that you might be working with machine learning, that could be terribly impractical. Excel certainly has limits to the number of rows we can load into a worksheet, 1,048,576 to be precise. But we might be working with excessive numbers and big data stores. So the other approach is that you can also do data preparation in the experiments themselves. All right, so I would suggest use the tool that makes most sense to you. If my data was in SQL Server, I might use T-SQL scripting, integration services, whatever it takes. Or I might choose to place raw data up there and do the transformations in the experiments themselves. So let's switch across now and create a new experiment within the workspace. And I think the name here is ideal. It is an experiment. And ultimately, if it proves to be valuable, then you can deploy it to become a manageable production resource. Now, when I create an experiment, just to show you that there's a great way to get started with this product, is that there is a growing gallery of different experiments that you can work with. For example, if I just put in a keyword fraud, and I know that I've got a fraud detection problem to solve, the best approach might be, well, let's just learn from other experts that are sharing both their data sets and experiments for me to learn from. Here in this demo, I'm just going to start with a blank experiment. And this isn't obvious, but the name of your experiment is here. So let's provide a better name for it, which is to predict customer profit. And for anyone that might be familiar with integration services with SQL Server, is there anyone in this room? The data flow in this product, simply components that perform some type of functionality, and we connect them to produce a flow. And so I can show you here under Save Data Sets that I have the uploaded data set. I can also show you that if I come to the data inputs and outputs, I could import data from other sources, with these sources being supported. All right, now, if you were going to use these sources, well then data cleansing and other preparation would take place inside the experiment. So let's take a look at how that could happen. First of all, let me visualize the data here. So bear in mind, this is just a web browser. There's no need to install any software. It just requires that you have a supported browser, which is all modern browsers, and internet connectivity. And you don't even necessarily need an Azure subscription. There's also a free subscription to work with Azure Machine Learning. So let's just take a look at the visualization of the data. And there are a couple of things that I need to do. First of all, I'm going to narrow the columns down even further. The customer ID I kept there, and that's always handy for you to go back to the source data if you need it. The other thing is that the profit value, that raw continual amount, should be removed. All right, I'm just interested in the label. And then lastly, I had some missing values for the total children. And I'd like to cleanse that by substituting missing values with 0. It's a little tricky to do it when it's not going to visualize my data for me. I did a run through this morning, which let me tell you is very wise, because while I presented this a number of times, Microsoft deploy changes from time to time, and there's nothing worse than being in front of an audience and things have changed on you, like they rename components and you go hunting for them. So I did run through it again this morning to make sure they hadn't broken any of my demos, and I had this issue this morning. It took about 2 or 3 minutes to actually visualize the data set. So let's come back to that, and I'll move forward to the next discussion. And that is that once we've prepared our data, we're ready to actually do the machine learning itself. And what that means is that we're going to develop models. And a model can be defined as an object that is processed by using an algorithm that will sift through your carefully prepared data, and it will extract patterns. And it becomes a queryable resource that we can then use for both exploration and for prediction. So the emphasis here is on plural. We don't just create one, we can create dozens. We could spend weeks determining what is the best algorithm, what parameters best tune, what inputs and what quality of data to get the output that we need. So I'm going to put hand in hand that we train models and we evaluate them, ultimately arriving at the best fit model fit for our purpose in terms of accuracy, reliability, and usefulness. Ouch. Okay, so not a lot I can do until I can have a look at what this data looks like. Are there any questions while it's still thinking about this?
So you've got the various connectors there. What's the kind of meaningful upper limit for updating, for uploading something?
For uploading of data, okay, if you're on the free tier, Microsoft will allow you to work with 1 gigabyte, but otherwise there's practically no limit. The data that you would upload would be stored in Azure Blob Store, and basically you'd be constrained by it. And so while it's thinking about this, how about I open up the Azure Machine Learning pricing. And so to answer those types of questions, there are some great FAQ sites, but also when I scroll down here, I'm sorry, did I say 1 gig? You've got 10 gig max storage. So potentially you could upload 10 gig of CSV data and mine from it. If you're prepared to pay for Azure Machine Learning, then it's basically an unlimited. There we go. That's the response I'm looking for. We're back on track. So the visualization that I've got, up front it tells me that there are 10,000 rows of data, 12 columns. The selection of a column would allow you to review some descriptive statistics about that column. We know that customer ID should not be passed into a machine learning algorithm. It's not a meaningful value that we expect it to correlate with some profit. We do recognize that total children has 10 missing values. And it's very, very important that I remove profit generated, because there's a direct correlation between profit generated and the label. Remember the formula in M that I used? We don't want it to be attempting to use it, because it will find a direct correlation very quickly. So 2 things that I'm going to do. The first is to remove some of those 12 columns. And if I just search across all of the modules by the word column, I've got one that's called Select Columns in Dataset. So it truly is drag, drop, connect, configure type arrangement. When I launch the column selector, I'm going to use a rule that says start with all columns but exclude these. That is the customer ID. That is also the profit generated. Next, I want to clean up those 10 with missing values. And simply by typing in missing, we'll find there's a module dedicated to cleansing missing data. Again, drag, drop, connect. And in this case, the default is that it is going to cleanse via a custom substitution. So which column? Well, let's go this time to no columns, but include by name the total children. So for that column, if it encounters a missing value, the default is it will substitute it with 0. But you'll see there are a full range of different cleansings that it might do. Afghanistani accountants go ahead and remove entire rows, etc. So we're now at the point where we have good quality representative data ready for machine learning, and I now need to give consideration to the algorithms that I'm going to use to train this data. So we will find them under the machine learning grouping. And we'll take a look at initialize model, and we have to start thinking about what we're really doing here. So of the 4 different groupings of algorithms, which is it that I'll be choosing from? predicting profitability in terms of a class, either very low, low, medium, or high. It's a classification. Whereas regression, if I was looking to predict the profit in terms of dollars and cents, it would be a regression activity. All right, so we look under classification, and then we see, wow, we've got this overwhelming list of available algorithms, and yet we could narrow this down very quickly to a subset. What criteria would I use to narrow them down? How many possible classifications do I have? 4. So is it 2-class? No. A 2-class would be a binary classification, quite common. Does this patient have the disease, yes or no? Whereas here, there are 4 possibilities. So it's really the multi-classes that I'll focus on. And then I find that I have 4, and it's like, well, I'm now confused which I should choose. And I'll draw you back to the object that you're working on, and it's an experiment. If you don't know, we'll try all algorithms, and then we'll have scientific measures or tests to evaluate what happened. So using a multi-class decision forest. And if you really want to know what it does, when the module's in focus, you just click on the More Help here, and the online documentation will give you a general idea about what it does, but it will also go into detail about how you may configure and fine-tune it. So when I scroll down, you'll see that there's a full range of parameters. They may not mean enough to you as a software developer or a database developer. A data scientist would probably come to terms with this more quickly. But again, part of your training is to experiment, make mistakes, learn from those mistakes. So what happens if I change it from 5 to 15? Does it improve the accuracy? And I'm about to show you the process whereby we can test the accuracy of the models that are trained. So I'm not going to change any of the parameters for the algorithm. We'll stick with the defaults. And having selected an algorithm, the next thing is to go ahead and train a model. So we drag in the module. It needs 2 things. What is the algorithm and what is the data? Now, before we pass data in order to test the accuracy of a model, we're going to split the data into 2 sets. 70% random set for training the models, and the reserved 30% will be used to test the accuracy. And given that that 30% knows what the outcome is, when it predicts, it can compare it to what actually happened, and it's a simple ratio of how often it gets it right is a measure of the accuracy of that model. So let's take a look at the split data module. Let's take the output of that cleansing, pass into the split data, and use a fraction of 0.7. So the left output will give me a 70% random set of the data, and then I can pass that into here to train the model on. What are we training for? I launch the column Selector, and we're asking it to learn how to predict the profit-generated label. Now, the next thing is to test how accurate it is. So this is machine learning. And do you remember you as a student at school? You did a course or a class, and you had assessments. And those assessments were scored, and therefore you were graded at how well you had learned the objectives of that class. So the models go through the same process. They get scored. So using that trained model with the reserved 30% of data, tell us how good it is at predicting. Now that essentially is the pattern. For simplicity in this demo, I'm going to copy and paste and produce another trained model. And this time, I'm going to use a different classification algorithm. All right, so here I'll use the multi-class neural network. And then using the same data in for training and the same data for scoring. And then lastly, what I'll do is evaluate the 2 models side by side, and that can be achieved through the evaluate model. Left-hand side, what was the score for the decision forest? Right-hand side, what was the score for the neural network? And now I click run. By the way, everything I've done so far hasn't involved any cloud service. It's just been a designer on my desktop. And now take a look in the top right corner, it's queued. And here it is running through the entire flow, sourcing the data from the data set, doing some preparation, splitting, in parallel training 2 modules, scoring them, and then an evaluation. You could
possible to link, so where you, let's say it was more complicated and I had one model that had 20
So you want one experiment, but you
Kind of branched it, so you've done two different techniques on one page effectively, but
what we could do is persist the data and then another experiment could pick it up. You could do it that way. But when you open up some of the gallery experiments, there's literally hundreds of modules, which is quite overwhelming, by the way. But what you'll find is that they're simply reusing the logic. There's a pattern and there's a variation on a theme. And once your data is prepared and split for a classification project, you'll just find there's lots of these going on. So don't be overwhelmed by seeing this spider web of connections. You can quickly break it down and understand the patterns. All right, this is a good sign. We have success. And when I right-click and evaluate, and visualize the result of this, we can see side by side, left-hand side decision forest, right-hand side neural network. The overall accuracy, for simplicity in this short demo, shows me 72% accurate on this side versus 77% accurate this side. Don't assume that a neural network is always going to be better. It just happens to be better for this configuration and this set of data. The confusion matrix down here actually shows us with the dark blue telling us where it got it right. So by the way, this is unusual. 78% is extremely good prediction. All right, so where it was high, it predicted high 78% of the time. That's because this is sampled data. But let me just ask you that if it came back and said 30% of the time I got it right, is there any value? Is this adding value beyond otherwise a random guess? And therefore a random generation of targeted advertising. So 30%, that would be good? I would agree. Anything above 25% is random. When you think of the four classes, if we had a four-sided coin, if one such thing existed, and you flipped it, well, that's a random. Whereas anything above the random is what we call lift. And that is the value that these prediction models can deliver to you. Translated into a better experience for your customers and hopefully increase sales and profitability, that's where you start to justify these projects. A marginal increase above guessing is going to translate to higher sales.
Isn't 30 instead of 25 within the standard deviation range?
Well, we're just talking in terms of randomness at this stage. A random advert would get it right 25% over the long term. Whereas what we're saying here is we've just proven that with 30% of our data that we're getting reliability is at 78%, and even 30%, even 26% would be better than random. All right, I've just worked through the entire life cycle then of training and evaluating, and I've made the decision that the model that's been trained by the neural network algorithm is superior, and I would like to deploy this. So we move on to the next part of the demonstration, which is to talk about publication. So as a cloud service, the way that we publish is via a web service. And so let me show you how this works in demo. The way that it works is you select the train model that you want. There could be dozens in your experiment. And then we go ahead and we set up a predictive web service. Watch closely as it creates a new experiment that is a predictive experiment. Wow, how cool is that? I think some developers in Redmond have been working overtime. But personally, I have a problem with what it just did. What you saw was it sort of collapsed those modules into the one that I selected. And what I don't like about that is it leaves you with a distinct impression that it has merged that functionality. To be honest, it should have just disappeared into the background. That decision forest model is irrelevant to this predictive experiment. It should have just disappeared, and that's what should have happened. But let me describe to you what has happened here. The dark blues represent the inputs and outputs of a web service. Remember that I'm looking for a function that if we pass customer demographics in, it will pass a predicted profit label out. What the blues represent are inputs and outputs. Rather than call this input 1, I'm going to call this customer profile, because that's what it is. And this one here is the output that I'm going to rename to become predicted profit class. Too easy. Well, what else has happened here? So you'll see that the CSV is still here. Here we now have a trained model. That trained model you'll also find available in your workspace for reuse across other experiments. All right, we don't want to retrain it every time we have a prediction. It's a trained model, and what this new experiment is doing is performing a prediction by using the trained model. All right, so what else it did was any of the transformations I had, removing 2 of the columns, replacing missing values, have been consolidated into a reusable transform. And that's also available to us within the workspace. And so you can think of it like a compiled transform that is going to be much more efficient than an interpreted one at prediction time. Now, this is when I started working with this. There was not a lot of documentation, but there's more work to be done than just accepting this new experiment that was created for me. And the first thing that I must do is come back to the select columns. Remember how I eliminated 2 columns earlier, but I must eliminate 1 more. Which is it? Yeah. That profit-generated label should not be used in a predictive experiment. That's the output, not the input. When we're training a model, we need it, but when we're predicting from it, so simply by removing it now, it understands not to ask for it as the input. I can also break this connection and say that the input should pass either direct to the transform, or in this case, I'm going to pass it straight to the score. Remember, the transform is really substituting missing values for total children. We know that we've fixed that. So during prediction stage, I know that it will not have to repair the number of children being missing. So there's my input going straight to a score that will use the trained model. And then the other thing I need to do is to only output 1 column. So I'll introduce another select columns, and I'll basically say, once you've scored, go ahead and remove all columns except. So let's say, begin with no columns and only include the scored labels. Very low, low, medium, or high. And with that 1 column, you may output that as the output. And there effectively is that function that I was looking for. Pass in customer demographics and then pass out a single label. Very low, low, medium, or high. We'll go ahead and run this, and that essentially validates that this predictive experiment makes sense. And once it determines that it makes sense, we publish this, and that essentially becomes the web service. Are there any questions while it's processing this?
Can we set up a continuous integration kind of thing where new data which comes in retrains the model?
So the question is, yes, a constant reprocessing. Well, yes, you can. So we could publish as a service a training experiment whereby you could just run this on a schedule every hour, ensuring that up-to-date data is available. So you'd probably want to use a cloud source of data. And yes, you could. So you could use a service that periodically retrains the model, and you could use another service that performs predictions against it. There was another question on this side.
I'm really inspired by this learning studio and how easy it is to structure them. And I guess, beyond this talk, with some reading to do, but what I know about machine learning, haven't yet, but there's lots of mathematics to get into, right? Like linear.
So what I'm hearing from you is, yes, the prerequisites to really drive a solution in machine learning requires good background in statistics and mathematics. Can I come back to that point later? I've got a slide that addresses what skills you'll need and perhaps how this technology can be approachable to you as an audience consisting largely of software developers. So I'll come back to that point. All right, I'm just conscious 1 hour is like really ambitious to get through this demo. So I want to then talk about the last phase of the project, which would be how would we manage this? So the next point would be we're going to deploy a web service, and that's easily achieved down here. Go ahead and deploy this as a web service. And within a matter of seconds, we've got an endpoint on the internet. We've got a key for authentication. There are, in fact, 2 different approaches when using the predictive service. We have the request response and the batch execution. Let me just show you for the request response, you can do a simple test. And here we can see those demographic attributes that must be entered. And if I were to fill in some values, it would give me a prediction back in the Azure portal. The batch execution service, in contrast, is asynchronous. So the first approach, request response, is like real time. Just shoot off, get a response back, integrate it. The batch execution service is asynchronous, and it will allow you to score typically, I've got hundreds or thousands of customers, and then output the scored results, and asynchronously I'll pick up those results from Blob Store later on. All right, from a management point of view, the Azure Ops teams might come and manage the web services for the workspace. And so the discussion here is really about scalability and performance. All right, so there's currently a single endpoint, but you could add in multiple to scale. You could monitor, because essentially in a production deployment, you're being charged in terms of compute time, but also the number of predictions. So we could monitor them here. And then under configure is where you can use the elasticity of the cloud and say, I need 200 compute units for this default endpoint, which Microsoft will guarantee under service level agreement to deliver up to 5,000 predictions per second. All right, so it is designed to scale and work at real time within applications. Finally, the topic that is of interest to you as software developers, and perhaps your involvement in a project might be simply integrating somebody else's deployed web service. So I've just introduced that when a web service is deployed, there are available to you two different methods: the request response for low latency, highly scalable web service versus the batch execution service for high volume yet asynchronous. The service can be called by any programming language and any device. You simply need to satisfy 4 basic requirements, and that is that your app needs internet connectivity, it needs to use SSL, it needs the OData endpoint and the API key for authentication, and then it needs the ability to work with JSON, whether you use libraries or you handcraft this through text manipulation. And so essentially it's open to any application experience, whether it's on a mobile phone, whether it's on a server. So let's now see through demonstration the integration of this predictive service in an ASP.NET web app. All right, so I'm going to open up Visual Studio, and I have an ASP.NET web app, so bear in mind this is not my strength as an ASP.NET developer. And let me just run it up front so you can see what my test is for this. Of course, in a real-world e-commerce application, you're not going to ask people to input their details, but this helps us test, what age are they, etc. And then when I click submit, it's going to call the predictive service. What it's going to display to us then are some images. So I have libraries of images here, and to keep it very simple, I just have 8. For male and female, I have a very low, medium, and high advert. And when I open up the web page, it's when I click submit that it's going to want to call the predictive service. All right, so let's see the logic. When we click submit, it's going to validate that there are no missing values. For simplicity, I have a class called customer profile, and it then has properties for all of the demographic states. So here, it's simply assigning the values from the controls into the properties of my customer profile object. Down here, we get to the point that I need some string that is the prediction of whether it's very low, low, medium, or high. So there's some work to be done here. Note that if the text error is returned, it's simply going, if it's not error, it's simply going to describe on the left-hand or the right-hand pane of the web page what the predicted class was, and then it's going to choose the appropriate advert based on the gender and the predicted class. So, to integrate this, when I deployed the web service, the responding page was this. Here is the API key that you're going to keep secure somewhere because it authenticates with the service. You're going to make a decision about which method, and I'll use the request response method. And then here on this web page is everything that you need as a software developer to integrate this web service, including the endpoint, including details of what the request needs to look like. And essentially, it's a JSON document as the request body. So take a look at this. There's one input named customer profile. It has these columns, and your values would need to be in here. And note you could submit more than one. You could comma separate and have multiple submitted in the one request. Upon success of processing that, a response will be returned, And essentially, it's going to be a JSON document that looks like this, and we need to extract the value from here. So whether you use JSON libraries to help you or somehow you just extract from that location, there's the prediction for you. Now to kickstart your development, down here we have sample code in C#, Python, and R. And so I'm simply going to select the C# code, copy it to the clipboard, switch back to Visual Studio, and add a new class to the project. They do to a degree. Does it look like I've lost internet connectivity? That's going to be interesting. All right, so Control-A, Control-V. There is all of that code. Now here's the problem. It's actually written as a console application, so it's not designed to be integrated into ASP.NET. Also, we'll notice some references are missing here. So let's fix that. The comments here tell me that if I install this package, tools, and you get package manager. So this is where it might fall down if I have no internet. I had an interesting challenge. The Ethernet connectivity in the room cut just before I started to present to you guys. But we have success, it's come back on. So collectively we cross our fingers in the room. Let me just reload a web page and see what happens. There's not a lot I can do at this point. Yeah, I'm on a different network, and I think what happened is it went to sleep, maybe because I'm not using it. Could you, what would you like me to do?
Plug that back in,
The problem is I'm working in a VM and it doesn't like the underlying network to change. So is there something perhaps you could just look at your phone? Maybe it's just failing this. I might have a solution that I can just open up and show you, but it's a little disappointing after all the effort we went to. So it looks like we have lost it. Let me just see what I've got as a backup. So under solution, essentially what I had to do was get rid of the main method as a console application that makes sense, but not in an ASP.NET web app. So I essentially just transformed the main method into a public static class here. Predict customer profit class, pass in a customer profile object, and return a string. And what the code gave me then, and the only change I needed to make then, was to actually pass my values to map into the columns. So to pass into the age column, use the age property of the profile. Use the marital status to pass into the marital status column. Next, I had to paste in the API key. You'd probably have it in a config file somewhere. And then you have the base address that was already in the sample code. It knows the endpoint for the web service, but again, that should be in a config file. Next, it actually calls the web service, at which point in time we have a response object, and providing that that response is returned to status 200, we can do something. If not, it returns the text error. If it was successful, what it needs to do is get the JSON string. That was the document, that was that response, and then somehow it needs to extract, and let me call this back to you. It needed to extract this value from the document. So I would just copy that and paste it to create some classes based on the JSON structure, and then programmatically I could deserialize into the object, and then here is the path. Within the JSON, you've got a results object, within it the prediction, within it the value, within it the values. They translate to the structure here. And ultimately the first column, first row gives me the text value, and then I would output it. And when I return it, I now have a method, which is that function, pass in demographic states, pass out prediction, and then I would come back to my default.aspx, and I would say, go ahead and call that static method. And then it could render the image. So just to finish off with what it would look like, and I apologize for the lack of internet, but I'm prepared for this. Here is a simulation of what could happen. And it's a shame because it really is real time, but it's so slick and fast. So I come in here and say, well, the customer is a middle-aged 45-year-old male, married, highest possible income, couple of kids, number of kids at home, not that it matters because our model couldn't use it, highest education, management, owns a home, commutes 5 to 10 kilometers. Then it's going to be an advert like this, right, to the male that's going to produce high profit. We'll encourage you with a Ferrari. If they were professional and earned less income, less education. It's still red, it has wheels, it's still a degree of sexiness, but it's going to appeal to someone that has lower disposable income, right? And then if we continue to work down, a skilled manual, lower money, lower education. And then what if they're a partial high school, low, single, manual worker? All right, and that's really what happens in targeted advertising. You know, what's the best bang for this particular customer? Do you think it'll change if it's a female? In retail analytics, the biggest discriminator is gender. The patterns between males and females are often very different. All right, so apologies that that demo didn't finish as planned, but that's essentially what would have happened. And I've got some links that will allow you to watch a video of that in more detail. So I just want to wrap up with the potential here and the message, and really in response to your question earlier. Yes, machine learning, we often think of data scientists as being the primary role, and yes, that's true. I mean, they develop the platforms, the algorithms, and produce very advanced solutions using these platforms. Yet there's a message for you guys in sense of applied machine learning. So applied machine learning is doing just what I did then. It's actually applying it. I didn't need to have a strong background in statistics. I needed the basics on how to prepare data, how to model it, and how to test the accuracy. I didn't need to have a master's or PhD in computer science to do that. So if you could do the same and you trusted the outcomes, well then I believe that this is approachable to you today as software developers. So just think about the potential, whether it's ad targeting, recommendations, churn analysis to know the customers that are likely to leave you, therefore what can we do to keep them, fraud detection and so on. There's a huge potential, and I'll draw you back to the galleries that will provide you a kickstart with sample data, sample experiments and documentation. So in summary, Azure Machine Learning as a cloud-based service provides a portal to engage with workspaces, to collaborate, to use a web-driven studio to access a range of cloud services and also upload data sets. You can then publish and deploy your web services to enable you to integrate predictive analytics into a full range of application experiences. All right, so in summary, Azure Machine Learning is a cloud-based service, fully managed, no need to install any software, integrated drag, drop, connect, best-in-class algorithms used and developed within Microsoft and some industry-standard algorithms as well. So Bing has been the major driving force, and that goodness is available to you through a range and a growing range of algorithms. There's been some subjects on R here this week. You can use R script and Python inside your experiments also. And as I've just pointed out, you can deploy and operationalize within minutes, providing you have internet connectivity. Key message to you guys as software developers: machine learning is approachable to you guys today. A series of resources. Pricing is a good one to look at. It is quite competitive, and especially the free pricing that allows you to experiment on your own terms at no cost. Not even a credit card is required to sign up and work with it. Here are a couple of links that will allow you to watch the full video, so I'm sorry I didn't get to demo the final stage of integration. And lastly, there is a couple of books and a number of books coming out. These are good because they talk to you from an entry level with no assumption you have machine learning background. If you don't agree with anything that I've said with machine learning, Paul the Octopus has a Wikipedia site here, and you might engage with him for your predictive requirements. Beyond that, we're out of time, but I'll welcome questions offline, and otherwise, thank you for your time, attendance, and interest. Thank you.